Here's another classic related rates problem. A police cruiser approaching a right-angled intersection from the north. So here's the intersection, and he's approaching it from the north. Is chasing a speeding car that has turned the corner and is now moving straight east. So the other car is moving straight east already. So we'll call this X, we'll call this Y. When the cruiser is 0.6 miles north of the intersection, so he's 0.6 miles north of the intersection, and the car is 0.8 to the east. So the car is 0.8 to the east, which means this is 1, conveniently, because 6, 8, 10 triangle. The police determined that the distance between them, meaning the police, and the car is increasing at 20 miles per hour. So this is increasing. So what is that? D what with respect to T? The distance between them. So what is that? D.
Y,
I'm going to call this D here. D equals 1 in this particular instant. So this is dd.
Okay.
dt. It's not dx or dy. It's dd. It's the distance. This distance is increasing at 20 miles per hour. If the cruiser is moving at 60 miles per hour, so that's d what? The cruiser is moving.
dy dt.
That's dy dt equals 60 miles per hour. But by the way, or 60 rather. Is that a positive or negative value?
Negative.
Yeah, it's going down, so that's a negative value because it's going down. Is moving at 60 miles per hour at the instant of measurement. What is the speed of the car? So what am I trying to find?
dx dt.
dx dt. So those are the variables that I know, and these are the variables I'm looking for. So this is a relatively simple equation because d squared equals x squared plus y squared. So let's take the derivative of this entire thing with respect to t. So this is 2d dt equals 2x dx dt plus 2y dy dt. And let's see what we know. We know that's 60. We know that is
20.
20. I didn't write that in there. Equals 20, and that's a positive because distance is positive. And we know the distance is 1, right? The x value is 0.6, the y value is 0.8, and so I've got
Not the other way around?
Did I do that wrong? Yes, you're right, I did it wrong, thank you. 0.8 is this, and 0.8 is the x, and 0.6 is y, right? Be careful with those things. So notice that I've got all of I had 1, 2, 3, 4, 5, 6 different variables, but 5 of them were given to me. 1, 2, 3, 4, 5. So all I need to do is plug and chug, and so this right here is 40 equals 0.8 times 2 is 1.6, and then I'm going to call this u because that's what I'm trying to solve for, plus 0.6 times 2 is 1.2 times negative 60. I'm running out of space here, so use your calculator. That's 40 plus 1.2 times 60 all over 1.6, and just punch that in and you'll find your answer, which is 70, I believe. And that is 70. So dx dt equals 70. And you want to say 70 miles per hour. Let's try another one. A particle moves along a parabola y equals x squared in the first quadrant in such a way that its x coordinate in meters increases at a constant rate of 10 meters per second. How fast is the angle of inclination of the line joining the particle to the origin changing when x equals 3? All right, that sounds like a mouthful, but let's draw out our picture here. You've got a particle moving along. Here's your y equals x squared in the first quadrant in such a way that the x coordinate is increasing. So dx dt equals 10. The x coordinate is increasing at 10. So the x coordinate is increasing at 10 meters per second. So let me draw this picture. Here's my, right there is the line that we're talking about. And this point up here is, of course, x, comma, y. And y, in fact, is x squared. So let's write x, comma, x squared. This right here, the angle of inclination of the line joining the particle to the origin, that is the angle of inclination that we're talking about. That's theta. So they wanted to find d theta dt. How is theta, the angle, changing with respect to time when x equals 3? So let's just think through this. Well, when x equals 3, y equals 9. And we can use that. Let me blow up this picture right here. Here's my picture. There's theta. This is x, and this is x squared. So you've got to use a formula that relates theta and x squared, and that, of course, is your tangent, because the tangent of theta is equal to the opposite over the adjacent. So that's your equation, and let's simplify that. The tangent of theta equals x. So that's the first thing that you're going to notice, is that you're going to use that equation. So let's go ahead and see if we can use this equation. Let's differentiate this equation with respect to t and see what else we need. So the derivative of tangent is secant squared theta, but then, of course, it's a chain rule, so d theta dt equals, and then the derivative of x is just dx dt. And so let's see what we have here. Well, we have dx dt already. Dx dt is 10, so I know that this is 10. D theta dt is what we're trying to solve for. Let me highlight that with a different color here. Trying to solve for that. And we also, well, now we need to find out what the secant squared of theta is. So now we have got to solve for secant squared of theta. Well, if you look at our original triangle up here, we can solve for that because we know a particular example. So when x equals 3, y equals 9, of course, and we know that the so at that point, Pythagorean theorem tells us that the hypotenuse is the square root of 90, and if you remember your formulas, the secant is equal to the hypotenuse, which is root 90, all over the adjacent, because it's the reciprocal of the cosine. So that's secant, and so secant squared is this squared, which means that's just equal to 90 over 9, which means secant squared is equal to 10. So this value right here, secant squared, is 10. So 10 d theta dt equals 10 means d theta dt equals 10 divided by 10, which equals 1, and that would be radians per second. So you solve that problem.